LLMs. You may have been hearing about this a little bit in your own exploration around AI. What is it? What is an LLM? Hari?
Yeah, so large language models are the underlying technology behind ChatGPT, behind Google Gemini, behind Claude. So all these generative AI products that you might have the consumer experience for. And these large language models, a lot of people assume, and the way that they are marketed to us, it almost seems like these are magic answer machines that are trained on the sum total of human knowledge, and they sure seem magical. You can ask them anything you want. They're everything machines. They will answer everything you post to them. They'll find the right answer for you. But there are really three fundamental things that I think people should know about large language models, that the companies themselves have said this is what people should know about them. So the very first thing to know is that they're actually not magic answer machines. They're not search engines. They don't actually have the sum total of human knowledge encoded in them. And so when you ask them something, they don't actually go find the answer within their large database and serve you the answer. What they actually do is they calculate the next sequence of words to stitch together into a sentence to give you an answer-shaped response, right? And so that answer-shaped response may or may not be accurate, may or may not be the actual answer, but they're not actually going and finding an answer for you. That's the first thing to know, is that every single time you ask a chatbot something, it's calculating a new response for you. It's not looking anything up.
Wow.
The second thing to know is, all right, so how is it calculating this response? And the way it's calculating this response is, again, not actually trying to figure out what are you asking for and then what's the right answer to what you're asking for. What it's actually doing is more of a complex word association game. And some people have called it like an autocomplete. It's a little bit more sophisticated than that. But even so, like this word association analogy is going to not be entirely there, but it's closer to what it actually does. So for example, if I wanted to know something about diabetes, right? And if I were to ask you, what are 5 words that you associate with the word diabetes? What might be some responses that you might give me? Blood sugar. Insulin. Overweight. Mustache. Mustache. Fifth one? Lifestyle. All right. So those are 5 responses, 5 words that are associated with diabetes that we asked from this audience. Now let's say I ask like 100 people what 5 words they would associate. And let's say we create a word cloud. And out of that word cloud, let's pick out the 5 most common words that people associate with diabetes. And then let's say I just ask some random person like Dennis over here to say, hey, here are 5 words, stitch a sentence together for me using these 5 words in any order you want. Right? And Dennis is going to make a sentence of those 5 words that are somewhat commonly associated with diabetes. And that's how these things generate an answer for you. Now, if it turns out in their data set, in their training data, if it turns out there are a lot of really good sources on diabetes, that word association game might result in something that's more or less in the right ballpark. But the way these things operate is they will give you an average answer, but they'll also randomly choose different words to put in there. So at some point, you might end up getting an answer for diabetes that says something about mustaches. And you might be like, what's this about mustaches? Right? And that leads to the phenomenon of these large language models are prone to what people think of as hallucinations. We'll get to in a second. Thinking about them as hallucinations is a little misleading because there's really no mind to hallucinate there. It's really just randomly adding different words based on its training data. So that's the second thing to know, is that because it's generating these words randomly, that the responses you get from a large language model-based generative AI product can never be guaranteed to be accurate or reliable. You ask the same question multiple times, you will get different answers from the same large language model. That's the second really important thing to know. A lot of people assume that you can summarize articles using large language models. It's not actually reading the article, it's not summarizing, it's just doing word association based on that article. So the third thing to know about large language models is those calculations that I mentioned, even if I were to ask 100 people, get those numbers, get those words through a word cloud, I have to now calculate probabilities. But now imagine that I asked 1,000 people, 1,000,000 people, 1,000,000,000 people, right? And I asked them, don't give me just 5 words, give me 1,000 words associated with diabetes, right? Now I've got 1,000,000,000,000 words to manage. So the computations involved in actually calculating the next sequence of words is fiendishly complicated, and it's really, really expensive. Right? So this means that every single time that you interact with a chatbot, you're actually firing off extremely expensive calculations that take place on extremely expensive machines called GPUs in an AI data center somewhere that needs an extreme amount of water and electricity. But we'll get to that in a bit.
We will. Adam, how are you feeling about this? You're in agreement with Hari's explanation of large language models?
Yeah. Mm-hmm.
So the naive person in me has believed until just this instant that all of these AI, Perplexity, ChatGPT, all of the ones that I've been using are actually pulling information from reliable sources like an encyclopedia or a medical text. But that is not what is happening based on what you've just described, Hari.
That's right. That's right.
That's very enlightening, actually. And also, to me, reinforces that I need to be cautious about the information I'm collecting off of an AI solution because it may not be accurate.
That's right.
Yeah, probabilistic, not deterministic, I think is the phrase that's like used. And I think it is like, it's a good foundation for using critical thinking skills and ethics and understanding like what the tools are capable of, what they're not capable of, their limitations, that they aren't human, that they are a machine and they are a product. So like all of this kind of should shape how you use these tools if you choose to use them or maybe you don't.
So that's the human element that we're all still going to need.
Right.
And as some of you may know, and you've probably had the conversations yourselves, that this could be the end of human intelligence. But we're going to dig deeper into that, right? Okay, so let's